guys, in this video we are going to look at expressions that require more advanced factorization. So if you look at the expression and you notice that the bases are the same, the variables are in the exponent, but the coefficients of the variables are not all the same, then this is how we proceed with that. We split the powers firstly. For example, if you have 3 to the power of x plus 2, it becomes 3 to the power of x times 3 to the power of 2. Don't forget to simplify the number further. That will become 9 times 3 to the power of x. Okay, the second step is if the coefficient is not 1, okay, if it's anything else but 1, then we rewrite it. And we rewrite it like this. If, for example, you've got 3 to the power of 2x, you can see that the coefficient of x is not 1, it's 2. So what we do there is we write 3 to the power of x in a bracket and we square that. Okay, so that's what we do next. Then the next step is to use the K method. So the K method is a crutch that we use to make our calculation easy. It simplifies it for us. An example of that would be if you had 9 times 3 to the power of x plus 3 to the power of 2x. So remember, 3 to the power of 2x, as we saw up here, gets split and rewritten as 3 to the power of x squared. Okay, then 9 times 3 to the power of x plus 3 to the power of x squared. So what we do is we let 3 to the power of x equal k. Therefore, 9, instead of 3 to the power of x, we are going to write k plus, again, 3 to the power of x is k, and this time it is squared. Okay, can you see it's easy to work with this instead of this line here? That means we take whatever's here in this last step that we did previously and we continue factorizing. And finally, we replace the k with the original. Now this is a very important step. We cannot leave our answer in terms of k. We've got to go back and replace k with what we substituted it with. So in this case, we had said let 3 to the power of x, if you look up here, 3 to the power of x is equal to k. When we get to our final step, k must get back to 3 to the power of x. So where you've got k in your final answer, you replace it with 3 to the power of x. Now let's look at a worked example. I've got 7 to the power of 2x minus 7 to the power of x all over 7 to the power of x minus 1. So that's going to bring us to 7 to the power of x all squared. Remember, we rewrite this if the coefficient of the exponent is not 1, minus 7 to the power of x all over 7 to the power of x minus 1. Okay, now we're going to use the k method to help us simplify this. And I'm going to take 7 to the power of x and let it equal to k. So let 7 to the power of x equal k. So that means wherever I see 7 to the power of x, I'm going to substitute it with the letter k. So therefore, 7 to the power of x is k squared minus k all over k minus 1. Okay, so that's equal to k squared minus k has got a common factor of k. Take that out. What's left is k minus 1 all over k minus 1. Now we notice that we can cancel k minus 1 and k minus 1, and we are left with k. Now be careful that you don't leave your answer as k, because we just used k to help us simplify. So we've got to go back. Notice in this step we let 7 to the power of x equals k. So if our answer is just k, we substitute it with 7 to the power of x, and that is your final answer. Happy practicing, guys, and I'll see you in the next video.